What's up, everybody? This is Mr. Tui, creator of the SAT Crash Course series. And in this video, I'm going to teach you how to solve a wide variety of SAT math questions using my unique and powerful test-taking strategies that simplify the questions. In fact, I'm going to teach you how to find the right answer on the SAT math section without any complex algebra operations at all. Oh, and by the way, if you like this video, you definitely want to access the full version of the SAT Crash Course series. It includes over 34 hours of the best SAT prep available anywhere. Just click the link in the description below to access the full version of the course. In the meantime, sit back, relax, and enjoy SAT Math Crash Course Day 1.
All right, welcome everybody to SAT Math Crash Course Day 1, Part 1. We're just getting started here. We've got a couple students with us, Ariani and Juliana. Say hi to everybody. Ariani and Juliana.
Hi. Hello.
All right. Thank you so much, ladies. All right. So before we begin, I want to express a couple things that I think are going to be helpful here, which is that the first thing is that the SAT is not nearly as hard as everybody thinks it is. And that's, I would say, is especially true for the math section of the SAT. Okay. Yeah, there's some algebra concepts on there, and it's helpful to have gone through Algebra 2, but I'll be honest with you, there's probably only about 4 or 5 questions on the entire SAT that really require a specific algebraic operation where you kind of got to go through step by step. The vast majority of the questions, you can simplify those questions using basic logic and turning a lot of the questions that even have variables where normally you might use algebra, turning those into arithmetic by plugging in values. So we're going to practice some of those strategies today about simplifying the questions. That's really the name of the game on the SAT is simplifying those questions. And if you can do that, the whole test opens up. And it's really pretty easy. You don't need much past like middle school arithmetic if you can learn to look at the questions the right way. Does that make sense, ladies?
Yes.
Yeah? Okay, good. All right. So, Juliana, I'm going to have you start us off here and read the first 2 rules for mathing. I've got those up right here. I'll bring them up. I want you to read the first 2 rules. We're going to practice these rules today and all the questions that we're going to be solving. Go ahead and read rule number 1. I think you're going to like it.
Avoid algebra whenever possible. Instead, plug in values for the variables and solve.
Yeah, and that's that strategy I was referring to earlier. You can turn almost all the questions that have variables in, we can turn almost all of them into arithmetic. And we're going to do that today. Now, you got to have your arithmetic down. We'll go over some of those operations. But this is not a difficult algebra test. You got to think very differently from your math classes. I'll show you how to approach those questions, but it's gonna simplify everything if we can avoid algebra and think in terms of values instead of variables. Go ahead and read rule number 2 as well for me, please, Juliana.
Eliminate incorrect answer choices using basic logic. For word problems, remember that you're dealing with real-world problems and real-world solutions. Yeah,
we're going to read some. We're going to see some questions where, just by reading the answer choices and just thinking in basic logical terms, you can be like, "Well, gosh, that value seems way too big. Like that would never work in the real world," you know. And if you can just think in those like really simple basic terms and kind of tap into your common sense, quite often you can eliminate 2 of the incorrect answer choices on a word problem, and sometimes you can even eliminate 3 of the incorrect answer choices on a word problem using basic logic. And then you've got your right answer without having done a single math operation. Okay? Does that make sense, ladies? How you can just use basic logic and common sense? Does that make sense?
Yes.
Yeah?
Yeah.
Okay, awesome. All right, so let's jump right into some of the questions. And we got question number 1 up on the whiteboard. Ariani, I'm going to have you start that one off. If you'll read question number 1 for us, please, and I'm going to guide you through this step by step.
If x minus 1 over 3 is equal to k, and k is 3, what is the value of x?
Okay, great. All right, what is the value of x? Okay, now, Ariani, how comfortable are you with algebra in general?
I'm pretty comfortable.
Pretty comfortable with it, okay. Do you think you would know how to solve this algebraically by kind of isolating x?
Maybe.
Maybe, okay, maybe. Juliana, how about yourself? Do you think you could isolate x and solve for x here? Do you think you could do that?
Maybe.
Maybe. Okay, that's okay. Look, we could go over that, and we're going to do some algebra here. We will. But I want to focus on this strategy of simplifying the question by plugging in values in place of the variables. We don't need to do any algebra here whatsoever. Okay? So here what we're going to do, and I would love you to help me out here as I solve this, Ariani. I'm just going to plug in values in place of the variables. I'm going to show you what this looks like exactly. Okay? So we're going to plug in For k, we're going to plug in a 3, right? Because they tell us that k equals 3 right here in the question. You guys see that?
Yes.
All right. So k equals 3, so we're going to plug in that k for 3. And then for the x, right, we know x is one of these 4 answer choices right here. X is either 2 or 4 or 9 or 10. Right? We know that. So we don't have to isolate and solve for x. We can just plug in the answer choices and test it and see if we get a true statement in the equation. Does that make sense, Ariane?
Yes.
Okay, so let's do that. I'm going to start on the whiteboard. I'm going to have you do some of the questions later on your own, but I'm going to start just to show you what it looks like. So I'm going to plug in answer choice A. Instead of x, I'm going to plug in a 2. So now it's 2 minus 1 over 3 equals not k. K equals 3, so I'm just going to plug in 3 for k. Okay, now take a look at that Ariane on the whiteboard. Does that give us a true statement, yes or no?
No.
No, it does not, because what do we get on the left-hand side of the equation?
3 over 3, which is...
Not 3 over 3.
1 over 3.
1 over 3, right? 1 over 3, which is 1/3. But even 3 over 3 wouldn't be a true statement either, right? But 1 over 3, which is not equal to 3. So we can eliminate answer choice A. Does that make sense?
Yes.
Okay. It's very, very important, Ariane and Juliana, and anybody else watching the recording, that when you're using this strategy of plugging in values in place of the variables, it's very important that you test all the answer choices. Okay? Because even if you see, like, one of them that work, or, you might see a couple of them that actually work if you're plugging in values. Here, we don't have to worry about that. It's going to be one of these is going to work and 3 of them aren't going to work. But you got to cycle through all the answer choices, and then you can feel really, really comfortable about the answer choice you've chosen. So I'm going to clear the screen. Let's plug in that 4 in place of x. We're going to test answer choice B. So we've got 4 minus 1 over 3 is equal to 3. Does that give us a true statement, Ariane?
No.
No, it doesn't, right? Because what do we get on the left-hand side of that equation?
That's 3 over 3.
That's 3 over 3, which is 1, right? Anything divided by itself is 1, and it's not equal to 3. So we can eliminate answer choice B. Is this making sense, Ariane?
Yes.
Juliana, is this making sense?
Yes.
Okay, excellent. All right, let's clear the screen, then we'll plug in answer choice C. So we're plugging in a 9 in place of x. So we got 9 minus 1 over 3 is equal to 3. That should refresh here on the whiteboard here in just a moment. I might have a little lag on the whiteboard this morning. There we go. All right, does that give us a true statement, Ariane?
No.
No, what do we get on the left-hand side of the equation there?
8/3.
8/3, right, which is not equal to 3. I don't even know what 8/3 is, but I know it's not equal to 3, so I can eliminate that. I sure hope answer choice D works, but it's looking pretty good right now. So I'm going to plug in that 10 for x. So we got 10 minus 1 over 3 is equal to 3. Does that give us a true statement, Ariane?
Yes.
Absolutely, right, because we get 9 over 3, which is 3. That is a true statement, so we can confirm that that is indeed answer choice D. Any questions about that, Ariane?
No.
Juliana, any questions about that?
Mm-mm.
No? Okay. Do you see how we're able to take what would normally be an algebra question and just turn that into basic arithmetic? Does that process make sense?
Yes.
Pretty much any question with variables, you can do this on the SAT. Again, there's just a couple exceptions, but for the vast majority, you can just use this strategy. Okay? So let's do the next question. And I would love it, Juliana, if you would read question number 3 for us, please, loud and proud.
On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages for each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon?
Okay. All right. Let's make it really, really clear here, Juliana. What are we solving for here in this question?
The total number of text messages that they both sent.
Yeah. So the thing you're solving for is always going to be in the last sentence of the question in a word problem. Always. Okay? And I encourage some students to underline the last sentence, or at least the thing you're solving for in a word problem. It always kind of clarifies things and gives you some direction about how to solve this. So we're looking for the total number of messages sent by Armand and Tyrone on Saturday afternoon. Now, if you're really comfortable, Juliana, if you're really comfortable with algebra, you might be able to look at this and kind of figure it out and figure out what the right answer choice is. Right, if you know kind of how variables work and you can think in algebraic terms. Do you think you know which one is the right answer choice?
No.
No, you don't know. Okay. That's okay. It's no problem at all. Some students that are really comfortable and have gone all the way through Algebra 2, should maybe even Algebra 1 should feel pretty comfortable doing this. But we don't have to think in algebraic terms here. Let's think in concrete terms, okay? I don't want to deal with variables like M and P, Okay, I want to deal with actual values and turn this into just arithmetic and common sense. Okay, so I'm going to set a value for m. Okay, I'm going to make m equal 1. Let's set that value. Okay, so m is 1. And then instead of dealing with p, I want to turn p into another value as well. I'm going to make p equal 0. Okay, 1s and 0s are great when you're plugging in values on the SAT. I think you're going to see that. Okay, so now this means something very specific. This means Armand didn't send m text messages each hour for 5 hours. He sent 1 text message each hour for 5 hours. Does that make sense, Juliana?
Mm-hmm.
So how many text messages did Armand send then? If he sent 1 text message each hour for 5 hours, how many did he send?
5.
He sent 5, absolutely. And Tyrone didn't send p text messages each hour for 4 hours. He sent 0 text messages each hour for 4 hours. Does that make sense?
Mm-hmm.
So how many did he send?
0.
He sent 0. Absolutely, right? And the question is asking us which of the following represents the total number of messages they sent on a Saturday afternoon. So could you tell me what's the total number of messages they sent on this Saturday afternoon? We're just adding them.
5.
5, absolutely, right? Does that make sense? We know if m is 1 and p is 0, the total number of messages sent is 5. Any questions about that?
Mm-mm.
No, okay. Now, how do we find the right answer? Well, we know m is 1 and p is 0. In this situation, we set those values. So all we got to do is take those values, plug them into the answer choices, and the correct answer choice has to give us 5. Does that make sense why?
Mm-hmm.
Great, let's do it. So let's plug in, and I'd love to see you work this out on the whiteboard. Let's plug in a 1 for m and a p for 0 into answer choice A, and then we'll solve that and see what we get. The correct answer choice, again, has to give us 5. Can I see you work that out on the whiteboard?
If I figure it out.
Okay.
Uh-huh.
There we go. So it's 9 times m times p. I love it. You use those parentheses. When you're plugging in values, absolutely use those parentheses. Perfect.
Okay.
So we get 9 times 1 times 0. This is perfect. You're doing great. All right, and what does that equal?
0.
That equals 0, right? Not 5. We know the correct answer choice has to give us 5 because anything times 0 is 0 here. So we can eliminate answer choice A. Does that make sense, Juliana?
Yes.
Okay, great. I'm going to clear some space on the whiteboard here for you. Let's plug in those values for m and p into answer choice B. It's 20. Yep, times 1 times 0. You're doing great. You're doing great. And what does that equal?
0.
0,
Again.
not 5. So we can also eliminate answer choice B because we know the right answer choice has to give us 5, not 0.
Mm-hmm.
So we can eliminate that. What about answer choice C? Let me see you plug in those values for m and p.
Uh-huh.
And that equals 5, so let's keep it. Let's keep it, okay? But remember, when we're plugging in values, you've got to cycle through all the answer choices because sometimes you'll see a couple answer choices that give you something that matches up, okay? But let's keep answer choice C, and we'll plug in those values now for D and test answer choice D.
Uh-huh.
Go ahead and plug those in now to answer choice D. And that gives us 4, not 5. So we can eliminate answer choice D and confirm, indeed, it is answer choice C. Any questions about that, Juliana?
Nope.
No? Ariana, do you have any questions about that?
No?
No? Does this strategy, is this starting to make sense of plugging in values in place of the variables?
Yes.
You can do it on almost every single SAT question. Almost every single one. At least it has variables, right? Okay. Let's go to the next question. Ooh, I like this one. All right, Ariane, go ahead and read question number 4 for me, please.
Okay. Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation?
Okay, good. All right, what are we solving for here in this question, Ariane?
The number of phones left.
No, we're not. Read the last sentence of the question again.
Oh, the 108.
Yes. What is the meaning of the value 108 in this equation? All right, again, in word problems, I can't think of an exception. So I'm going to say every time in a word problem, the thing you're solving for is in the last sentence of every question.
Okay.
Always. So focus on that. So what is the meaning of the value 108 in this equation? Okay. All right. So we're looking at this equation up here, right? P equals 108 minus 23D. Okay. And I'm guessing, because it was the case when I first saw this question, and it's the case for most students I work with, like just looking at that equation, it's not obvious what 108 means in that equation. Would you agree with that statement, Ariane?
Yes.
Okay, yeah, it's not obvious at all. Okay. So don't worry about the equation right now. Let's just think in common sense terms. Okay? Let's just think about like basic logic here. Let's read the answer choice. Let's just test them and see if that would work in the real world, if that makes sense in the real world. Okay? Now, if we can't eliminate it, let's keep it. If we're like unsure about it, we'll keep it as an answer choice. But if you're reading like, well, that's just crazy, that would never work, then we can eliminate it. Does that make sense?
Mm-hmm.
Okay. So go ahead and read answer choice A.
Kathy will complete the repairs within 108 days.
Okay. Is that a reasonable statement? Is that something that might work in the real world?
Yeah.
Yeah, maybe. I can't eliminate it. 108 days sounds like a long time to complete some repairs, though.
Yeah.
Would you agree with that? It seems like a long time. I'm a little bit suspicious of it, but I can't eliminate it, so I won't. Okay, does that make sense? Okay. Go and read answer choice B for me, please.
Okay. Kathy starts each week with 108 phones to fix.
Okay, would that work in the real world? Is that a reasonable statement?
Yes.
Maybe, yeah. I mean, I can't eliminate it, right? I can imagine someone having a job where they've got to fix 108 phones in a week.
Sure.
Right? I can imagine that. All right? Kind of just like answer choice A. Again, answer choice A, it seems like a long time, but I can keep answer choice B as well. But go ahead and read answer choice C.
Kathy repairs phones at a rate of 108 per hour.
Yes. Laughter is the appropriate response to that. All right? Because I want you to think about that for a minute in like basic, common sense, logical terms. Is it possible that someone could repair phones at a rate of 108 phones per hour?
I don't think so.
Probably not. That's crazy. Think about that for just a minute. Juliana, does that make sense? Why that's kind of a crazy sounding answer choice?
Yeah.
Right? I mean, if you're fixing 108 phones per hour, it's more than a phone per minute. It's almost 2 phones per minute. That's crazy.
Yeah.
That would never work. I can't even imagine a situation where that would unless like fixing just means pressing a button and she's just flying through them. But like that wouldn't work. All right, and kids are gonna pick answer choice C because they're like, oh, I don't know, pick C, right? When you don't know, pick C, and they're gonna pick it, but it doesn't make any sense. And these are real world questions that have real world solutions, so it has to make sense in the real world. It's got to be common sense. Go ahead and read answer choice D for me, please, Kathy.
Kathy repairs phones at a rate of 108 per day.
What do you think about answer choice D? Is that something that would work in the real world? Is that reasonable?
It is.
It's possible. That's fast though.
You
know what I'm saying? I'm suspicious of D. Because if you think about it for a minute, let's say you're working an 8-hour day. Okay? Then she's fixing like, I don't know, close to like 12 phones in a day, something like that. Or 12 phones an hour. That's like a phone every like 5 minutes. That still seems fast. That might be possible. Let's keep it. Okay? Again, we don't have to eliminate it. Okay? But I'm suspicious of A and I'm suspicious of D. And I think B, just in common sense terms, kind of makes the most sense. Okay?
Mm-hmm.
All right. So if I were guessing, I'd just pick B. Okay?
Yeah.
But now, let's use that strategy of plugging in values in place of the variables. Because you can really combine both. Okay? So let's plug in some values for D, the number of days she worked. Okay? So here's what I'm going to do. I'm going to create a value for D. I'm going to make D equal 1. Okay? Now think about this for a minute. I'm not just making D equal 1. This statement has meaning. This means Kathy has worked 1 day. Does that make sense, Ariane? When I say D equals 1, that means she's worked 1 day. And then P is the number of phones she has left. So I can easily calculate the number of phones she has left when I plug in a 1 for D. That is after she's worked 1 day. Okay? So I'm going to plug that in. I get P equals 108 minus 23, not times D, but times 1.
Mm-hmm.
Okay? Does that make sense?
Yes.
Okay. And, this is a non-calculator section question. You can use your calculator here if you want to, just to save time. What is that going to equal? We're going to get 108 minus 23. Do you know what that equals? Juliana, do you know what that equals?
85.
Yeah, that's 85. Okay. Again, you could do the arithmetic there. It's not, it's not too complicated, but I'm just trying to save a little bit of time. All right, so let's think about this for a minute. This means after Kathy has worked 1 day, she has 85 phones left to fix. Does that make sense?
Yes.
Okay. Let's plug in a 2 for D. I'm going to make D equal 2. Okay. Let's make D equal 2. And so now the equation is P equals 108 minus 23, not times D, but times 2, which is going to be 108 minus, I think, 46. What is that going to give us?
62.
62. Interesting. Okay. So after she's worked 1 day, she's got 85 phones left to fix. After she's worked 2 days, she has 62 phones left to fix. Interesting. How many phones is she repairing every day, Ariane?
23.
I think she's fixing 23. So now we know the meaning of 23 in this equation right here. That's the number of phones she's fixing every day. Does that make sense?
Yes.
How is it going to take her 108 days to fix these phones?
No.
I don't think so. Right? How long is it going to take her to fix these phones? I mean, if you're just going to estimate.
5.
Something like 5 days. Something close to that. Absolutely, right? So now we can eliminate some other answer choices. Which answer choices can we eliminate?
The phones at 108 per day.
Yeah, if she's not fixing 108 phones per day, she's fixing 23 phones per day. What else can we eliminate?
And A.
A, right? Because it's not going to take her 108 days. Now, it's a true statement. It's going to be within 108 days, but that's not the meaning of 108.
Yes.
So answer choice B is looking really good. Does that make sense?
Yes.
Okay. Now, we can confirm answer choice D. Let me show you how. It's real easy. Let's plug in a 0 for D. We're going to make D equal 0. Now, think about what this means. This means she hasn't worked any days this week. Does that make sense, Ariane?
Yes.
Okay. She's worked no days. So we'll plug in that 0 for D. So we get P, the number of phones she has left, equals 108 minus 23, not times D, but times 0. And how many phones does she have left to fix after she's worked no days? The start of the week.
108.
108, which is the start of the week. Does that make sense?
Yes.
We can confirm it's answer choice B. Juliana, any questions about that?
Nope.
No? Now, do you see how you can combine those two strategies of using common sense, right, and basic estimation, and also plugging in values? The two work hand in hand. And once you start plugging in values, sometimes kind of what works is just much more, in the real world is much more obvious once you start dealing with actual numbers. Okay?
Yep.
All right. Let's keep rolling. You guys are doing great. Juliana, you are up. Go ahead and read question number 6 for us, please.
The pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age, A, in years, between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year?
Okay. All right. So, Juliana, what are we solving for you in this question?
The estimated increase of a boy's height each year in inches.
Absolutely. Right against that last sentence in the question. What's the estimated increase in inches of a boy's height each year? And that's between the ages of 2 and 5. Okay? Does that make sense?
Mm-hmm.
Okay, great.
Yes.
Now, before we start doing any math here, let's just kind of look at the answer choices. Okay, we're talking about how much a boy grows each year between the ages of 2 and 5. Do you have little brothers or sisters, Juliana?
Nope.
No? Ariane, do you have little brothers or sisters?
Yes.
You do. Okay. So you might be looking at the answer choice already, and maybe even you, Juliana, as well. Even if you don't have little brothers or sisters, think about like how fast little kids grow or how fast they don't grow. Juliana, I think we can look at some of these answer choices and say, well, that answer choice, those answer choices are just a little bit crazy and would never work in the real world. What answer, if you're going to eliminate some answer choices, Juliana, what would you eliminate?
D immediately.
D is insane. Think about that for just a minute. 14.3.
Really tall kid.
That's going to be a really tall 5-year-old. Right? That's going to be like a 6-foot tall 5-year-old. Right?
Mm-hmm.
Something close to that. That's crazy. Can you eliminate any others?
I think C too.
Even C is a little bit suspect here. All right, I'm very suspicious of like that's we're talking like 10 inches per year. That's almost a foot per year. You're still going to be dealing with like a 5-foot tall 5-year-old. Okay, which is a very terrifying thought. So I think we can eliminate answer choice C and D pretty easily right off the bat. Any questions about that, Juliana?
Nope.
Ariana, does that make sense too?
Yes.
Okay, good. So even if this is as far as we get, we've eliminated 2 answer choices. We have a 50-50 shot on a tough question. And those are pretty good odds. And if you can do that, you're playing this game the right way. Look, the SAT is just a game. It's a weird game, but it's a game. And it's a bunch of little puzzles. That's all it is, okay? And if you can increase your odds of getting the answer choice right, you can cut, like, if you can, instead of just guessing 1 out of 4, if you can guess like 1 out of 2 on the questions you're guessing that you don't know how to solve, you can cut the questions you're getting wrong in half just by eliminating half the incorrect answer choices. And that could give you a major boost on the SAT. So that strategy alone is huge. Okay. All right. So, all right. But we don't have to guess here. Right? Because we're solving for the estimated increase in a boy's height each year. We can plug in values into this equation up here. We can plug in values. Okay. Now, we can't plug in the answer choices because that's the estimated increase in boy's height each year. But we can plug in values for A, right? Because if we can find out how tall he is, remember, his height is the H value. If we can plug in the A values, we can find out how tall he is when he's 2. We can find out how tall he is when he's 3. And we can find the difference, how much he's grown between the age of 2 and 3. We can find out how tall he is when he's 4. We can find out how tall he is when he's 5, right? And we can just see how much he grew each year. Does that make sense, Juliana?
Yes.
Okay, so let's do that. Let's just plug in values for A. Okay? So I'm going to guide you through this, but I need your help solving this. So we're going to plug in we're going to start with 2 for A, right? So it's 3, not times A, but 3 times 2 plus 28.6. Now this is going to tell us how tall he is when he's 2. Does that make sense?
Yes.
Okay, and how tall is he when he's 2? It's going to be 6 plus 28.6. Again, you can use your calculator here. I know you can solve this by hand.
34.6.
34.6 inches. Okay. When he's 2. Does that make sense?
Mm-hmm.
Okay. That's when A is 2. Let's make A equal 3. So it's 3. Not times A, but 3 times 3.
Mm-hmm.
Plus 28.6. What's his height when he's 3 years old?
37.6.
37.6. What's the increase there?
3.
If you were going to guess between A and B, what would you guess?
A.
A. And if you wanted to, you could plug in a 4. I think you would get 4 for A, and you get like 12 plus 28.6. You get 40.6, another 3-inch increase. But we don't need to guess there, right? You just calculate how tall he is at each age by plugging in the values. Juliana, does that make sense?
Yes.
Okay. Now, we're on like question number 6 so far. All the questions we've done so far, these are from the same practice test. And they're all from the same section of the same practice test. I'm not just like picking and choosing the easiest ones.
That's why they're so familiar. I remember them.
You might have done them before. That's SAT practice test number 1, right? It's usually where everybody starts. If you've done some prep on your own, absolutely. Yeah, but I'm guessing you weren't solving them this way, were you?
Mm-mm.
No, nobody does, right? Because in a math class, you learn to do things in terms of operations. You're like, okay, here's a question. It looks familiar. What are the steps I go through? And it's not like that in the SAT. It's like, okay, let's start thinking in concrete terms. Let's start thinking about values. Let's see what would work in the real world. Let's see if I can figure this puzzle out. Right? That's the SAT. Totally different way of approaching the questions. And really, it's about testing the answer choices much more than just solving it. Start with the answer choices. Start with what's reasonable. And then the whole test is just so much easier. Oh, this one. In fact, I think all the ones we're going to be working on today are from the same practice test. This is all from section 3 of practice test 1. Okay? Go ahead and read, let's go to Ariani. Go ahead and read question number 8 for us, please, up on the whiteboard.
If a over b is 2, what is the value of 4b over a?
Okay. How can we solve this, Ariani, by plugging in values in place of the variables?
We could just make them 1 or 0.
We could do that. Let's try that. Let's set a equal to 1 and b equal to 0. But I'm looking at this equation right here in the question, and I don't think we can pick 1 and 0 for a and b. Why not?
Well, we can't do it that way because b is the denominator.
Yeah. 1 divided by 0 is not 2. In fact, you can't even divide anything by 0. Right? Do you see that?
Yeah.
So this is a really good example of a question where you can't just pick anything. Sometimes you can just pick anything. But here, we're limited sort of by the values that will work with the question. We've got to pick values for a and b such that a divided by b equals 2. Now, we can pick anything for a and b as long as a divided by b equals 2. But a divided by b has to be 2. So give me some other values for a and b.
2 and 1.
I love it. 2 and 1 would work. 4 and 2 would work. 8 and 4 would work. Right? As long as a divided by b equals 2, we're good.
Okay.
Yeah. Does that make sense?
Yes.
Okay. Now what do we do to find the value of 4b over a?
So 4 times 1 over 2.
Yeah. We'll just plug it in. Plug it into this expression right here. So it's 4 not times b, but 4 times 1, because we set that value for b, divided by 2. And what does that give us?
2.
Gives us 2, which is what answer choice?
C.
C. Absolutely. It's that easy. It's that easy. Any questions about that?
Nope.
Juliana, any questions about that?
Nope.
What's funny, I remember seeing this question for the first time and not having a clue what to do when I first started tutoring. I looked at it, I'm like, I don't know. I don't know what to do. I didn't know the operation. But again, I wasn't thinking in terms of plugging in values for the variables. I was thinking about what are the steps? And I didn't know the steps. But you don't have to know the steps if you can turn to arithmetic, which we can by plugging in values for the variables. Any questions about that?
Nope.
No? All right. Let's keep rolling.
Nope. Oh, I remember this one.
Question number 9. All right. Whose turn is it? I think it's Juliana's turn, right?
Yep.
All right. You've got some traumatic memories of question number 9?
They weren't really traumatic,
Yeah.
but
Okay.
I remember it.
All right. Go ahead and read question number 9 for us, please.
What is the solution xy to the system of equations above?
Okay. All right. Now, clearly, they're testing us on systems of equations here. Right? There's no question about that. And they give us the 2 equations up there at the top. You can solve this algebraically by using either the substitution method or the elimination method. Are either of those familiar?
Yes.
Yeah, okay. You can do that. And in fact, on my rules for mathing, I've got a section on systems of equations. I go over the elimination method. I recommend using the elimination method if you have to carry out the specific algebraic operation. And maybe on half of the systems of equations questions on the SAT, you do have to do the actual, like the actual steps. Sometimes you do, okay? And you could here, but you don't need to. We can turn this into arithmetic. Why can we turn this into arithmetic, Juliana?
Because you can plug in the xy values.
They give us all the potential xy values right here. So we can just test the answer choices. Does that make sense?
Yes.
Did you do this when you solved it on your own or no?
No.
No, right? Because you're trained to go math mode, system of equations, use the elimination method, right? And you can do that. That's fine. But like, there's so many steps, and it takes so. But like, we can just turn this to arithmetic. So let's do it. Let me see you plug in our values from the answer choices into the system of equations. Remember, these are XY pairs, right? So let me see you plug in a -5 for X and a -2 for Y into the equations. Let's see if we get true statements. Can I see you do that on the whiteboard?
Yes. 3.
Looking good, looking good.
How do I move it over so there's more space?
There's a little hand on the right-hand side. You can click on the hand. You can kind of scroll over.
Uh-huh. 3.
Okay. All right, let's simplify that. Let's get our arithmetic down here. Yep, 3 times -5 is -15. Remember, a positive times a negative is negative. And again, positive times a negative is negative.
8.
Excellent. All right, does that equal -23?
Yes.
Yeah, it does. -15 plus -8 is -23. Okay. And again, if you need to go over like the basic, arithmetic. This is like middle school arithmetic. Just do some. There's great YouTube videos. Just do a search or something like that if you need help with the arithmetic. But yeah, it's that simple there. All right, but now we got to also plug into the bottom equation. We can't just stop there. And I love. Well, hold on, just a second. Right, it's 2 times y, and what's the y value?
The -2.
-2, right? Not -5. That's where they get you sometimes.
Yeah.
Good. Okay. Now hold on. It's minus -5, not -5. Do you see that? Remember, x is -5.
Yes.
Do you see that? So this is where I'd still use the parentheses when you're plugging in values. Yep. And when you subtract a negative, right, it's the same as adding.
A positive.
Yep. Does that give us -23? Don't even worry about what that is. Is it going to be -23?
No.
Or I'm sorry, -19. I meant -19. No, it's not -19. So we can eliminate answer choice A. Does that make sense?
Yes.
Okay, great. I'll clear some space on the whiteboard here for you. And go ahead and plug in a 3 and a -8. And I think answer choice B works. So you don't have to worry about going all the way, doing this all the way through D. I think this is going to work. But let's confirm it. So you're plugging in 3 for X here. It's looking good. And you're going to plug in that -8 for Y. Ariane, do you feel pretty comfortable with this arithmetic here?
Yes.
Okay, good. I think most students do. And again, if you're not super comfortable with dealing with negatives and stuff like that, do some, YouTube is great. But I think most students can do that. Is that a true statement there, Juliana?
I think so, yes.
Yeah, absolutely. Right. I mean, it just feels right. 9 plus, this can be -32. Right?
Mm-hmm.
That's good. So let's plug it into the bottom equation now.
2.
And y is -8. Good. Minus, and use your parentheses here. That's 3. Good. Which isn't an issue here because it's not a negative, but I still recommend it. Does that give us a true statement?
No.
I think it does.
Does it?
Yeah, because we get -16.
Oh, yeah.
Right?
You're right.
Minus 3, right? Which it does equal -19. Does that make sense?
Yeah. Mm-hmm.
Okay. Where were you getting thrown off there, Juliana?
I think I just somehow managed to add the 2 and -8.
Oh, okay.
So I got n.
Because it looks like 2 minus 8, right? But it's 2 times -8.
Yeah.
Yeah. Gotcha. Okay. So it is answer choice B. I would stop here probably. I mean, you could cycle through all the answer. If you had extra time and wanted to check at the end, you could.
Yeah.
You probably won't, not going to lie. They don't give you a whole lot of time on section 3. I mean, they give you 25 minutes to do 20 questions. So, if you get something here that matches up, and you feel you feel confident in your arithmetic, I would probably stop. But if you got time to go back and check, you could do that too. And then you would feel really confident about your answer choice. Any questions about that, Juliana?
Nope.
Ariane, any questions about that?
Nope.
No? Okay, rock and roll. You guys are doing great. Question number 11. Ooh, this one's a little bit different. Ariane, go ahead and read question number 11 for us, please. I'm proud.
Okay. In the equation above, B and C represent the price per pound in dollars of beef and chicken, respectively. X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken?
Okay. Ariane, what are we solving for here with this question?
The price per pound of beef when it was equal to the price of chicken.
Yes, and you're just reading the last sentence of the answer choice, or of the question. What's the price per pound of beef? What's equal to the price per pound of chicken? Okay. For some number of weeks after July 1st, right? That's X weeks. Does that question make sense, what we're solving for here?
Yeah.
Okay. It's like, when does B equal C? When does beef equal chicken? Or the beef price equal the chicken price? Okay. Now, there's a way to solve this sort of algebraically. Okay, what you can do is you can set both equations equal to each other, because B is going to equal C, and then solve for X, and then once you know X is, plug that back into the answer choices, or plug that back into the equations at the top. And if that didn't make any sense, don't even worry about it. We don't have to go to that direction. Okay, we can still plug in values in place of the variables here. Okay, and the key to this is realizing, if you look at the answer choices, Ariane, are we talking about a large value for X or a relatively small value for X? The number of weeks.
It's kind of small, I guess.
It's kind of small, right? Because like the biggest value for the prices here is $3.35, which isn't super expensive, right? And if we look at that first equation, that beef equation, for example, that would be when X is 4.
Okay.
Does that make sense? Right? Because
Yeah.
that's that 0.25. That's 25 cents.
Yep.
So 0.25 times 4, that's $1. Plus 2.35, that would be 3.35. So X can't be bigger than 4. Does that make sense?
Yes.
So it's probably going to be something, and it can't be 0, right? Because the smallest price is 260.
Yes.
So it's something between 1 and 4, right?
Yep.
Let's just test those values, right? Let's make X 1. We'll see if the beef price equals the chicken price. We'll make X 2. See if the beef price equals the chicken price. Does that make sense?
Okay. Yes.
Great. So, and again, you know, this is the non-calculator section, but right now, if you have a calculator handy, just for the sake of simplicity and time, I'll let you use it. But you might be able to do this in your head because it's money, right? Think in concrete terms. This is money. We're counting change. This is like early elementary, right? Counting change. I hope it is in early elementary. So when X is 1, let's set that value. What's the beef price?
$2.65.
I don't think it's $2.65.
Oh, 55. Sorry.
Nah, I don't think so. I think it's $2.60. Correct me if I'm wrong. Are you using your calculator?
Oh, yes.
It's $2.60, I think, right? Because it's $2.35 plus 25 cents. So that's going to be $2.60.
Yes.
Does that make sense? Okay.
Yep.
What's the chicken price?
$2.15.
$2.15. Yeah. Which are not equal to each other. So X isn't 1, and I can eliminate answer choice A. Because I know when beef is $2.60, the chicken price isn't $2.60.
Yes.
Does that make sense?
Yep.
Yeah. Okay, great. All right, so let's try 2. Let's make X equal 2. So when X is 2, what's the beef price?
$2.85.
Yeah, $2.85. Right? I can do that in my head, right? It's just $2.35 plus 50 cents. That's $2.85. I used to work at Starbucks, and I used to work the cash register, so I've got my change counting skills. They've never left me there. And then what's the chicken price? It's going to be $1.75 plus 80 cents.
$2.55.
$2.55. Right? So it's X isn't 2, And I can eliminate answer choice B because when beef is 285, chicken's not 285. Does that make sense?
Yeah.
Okay, great. Let's do it again. Let's make x equal 3. What's the beef price when x is 3?
3. Sorry. 310.
310. What's the chicken price?
295.
Yeah, that sounds right. 295. All right, still not equal.
Yep.
And we can eliminate C, right? Because when chicken's 295, beef isn't 295.
Yeah.
Answer choice D is looking good. I sure hope it works, but I think it does. Actually, I know it does, but but still, we'll go through it. Let's set x equal to 4. We know it can't be bigger than 4. What's the beef price? We already talked about it.
335.
335. What's the chicken price when x is 4?
335.
335. Bingo. Answer choice D. Any questions about that?
Nope.
No? Juliana, any questions about that?
Nope.
Okay, great. Now again, if you're super comfortable with the algebra, you can do the algebra here. I'm not saying you can't do algebra. Okay. I'm just saying if you can turn it into arithmetic, it's probably going to be a little bit easier. You're more likely to get the right answer.
Mhm.
And you're going to avoid this kind of the silly mistakes when you're doing a lot of operations. If you're just doing basic arithmetic, students just make fewer of the silly mistakes that they tend to make with algebra. You're just much more likely to get it. Okay. All right. Let me look at the next question. We might take a little break here, just a moment. We might do the next question. Let's do this one. Let's do this one. Go ahead and read question. I think we're on Juliana now. Go ahead and read question number 13 for me, please.
If x is greater than 3, which of the following is equivalent to 1 over fraction?
Yeah, that whole messy fraction, right? Okay. That is a mess. Okay. Woo! What are we solving for here, Juliana?
The fraction with the x is greater than 3, which is equivalent
Yeah, we're trying to find the equivalent expression to this expression right here.
to that mess.
Right. What to that mess? Yeah. One of those answer choices is equivalent. What does equivalent mean, Juliana?
Equal to.
Equal to. Right. By the way, if you see a vocab term you're not familiar with, I've got a glossary section on my rules for mathing, and check that out. Equivalent is one of the terms you need to know. Just means equal to. Okay. Okay. All right. So here's the deal. This is not nearly as hard as it looks, because we are going to plug in values in place of the variables here. Okay. We're going to create a value for x. Okay? And we're going to plug in that value for x into the expression of the question. Okay? Then we're going to find out what that equals, right, in terms of like actual numbers. And the correct answer choice, if it's the equivalent expression, if it's the equal expression, has to match up with that same value. Does that make sense, Juliana?
Yes.
Okay. Okay. And if not, it's going to make sense here in just a minute for anybody watching the recording. Okay, now here's the deal. On equivalent expression questions, okay, if two expressions are truly equivalent, truly equal to each other, does it matter what x is?
No.
No, it can't. If they're truly equivalent, x could be anything. It could be negative a million. And the two expressions will be equal if they're truly equivalent. Here's the deal. This is one of the few times where we can ignore this statement right here. If x is greater than 3. We can totally ignore that. Okay? So the whiteboard's like, there we go. We can ignore that. The only reason they're telling us if x is greater than 3 is to keep us from doing what we're about to do, which is really simplify this question. Okay? We're going to create a value for x. We're going to plug in, and we're going to make x equals 0. It's going to make this so easy. Well, relatively easy. Okay? X is equal to 0. Right? Now, I know you might be like, oh, the x has got to be greater than 3. I used to solve this by plugging in 4. I used to not mess with this. But they love being like, oh, if x is some bigger value. Again, they're just trying to keep you from doing what we're about to do. That's all they're trying to do. But we know better now. Right? If you understand what equivalent means, it doesn't matter what x is. Okay? All right. So x is great. It's the only exception we can ignore the limits they give you in the question. It's the only exception. But it's an important exception. So if x is 0, let's plug that into this expression and find out what that equals, okay? I'm going to start working that out on the whiteboard, but I need your help to solve it. So we get 1 over, what's 0 plus 2?
2.
2. Plus 1 over, what's 0 plus 3?
3.
3. Okay, so it's 1 over 1/2 plus 1/3. Does that make sense so far? That's what we get when we plug a 0 in for x into that expression of the question. Does that make sense?
Mm-hmm.
Okay.
Yes.
Now we got to talk about operations with fractions a little bit.
Yay.
Okay. Do you know how to add 1/2
Yes.
plus 1/3? Okay. How do we add that?
You have to get a greatest common factor.
Yeah, well, a common denominator, right?
Mhm.
Common denominator. What's our common denominator going to be?
6.
Let's make it 6. Okay, so we're going to have to express 1/2 with a 6 in the denominator, 6 in the bottom of the fraction. How do we do that?
You multiply the 1/2 by 3 to get 6, and then you do that to the top.
We're going to multiply by 3 over 3. Okay? Juliana, what's 3 divided by 3?
1.
1. And what's anything times 1?
Itself.
Itself. So we're not changing the value of 1/2 by multiplying by 3 over 3, but we're going to change the form of 1/2. Ariane, does that make sense as well?
Yes.
Okay. And even if you just look at it, when we multiply, we multiply across the numerator and across the denominator. When we multiply fractions, we get 3 over 6. But 3 over 6 even feels like 1/2. You know what I'm saying? Because it is 1/2.
Mm-hmm.
It's the same thing. What about 1/3? How do we express that with a 6 in the denominator?
You do 2 over 2.
Multiply by 2 over 2. And what do we get? And multiply
2
across the
6.
numerator. What? Yeah, 2/6. 2 over 6, which even feels like 1/3, again, because it is 1/3. And what does that give us? In the
5
denominator.
over 6.
Gives us, 1 over 5 over 6. Okay? Now here we got to be like, oh no, we're dividing by fractions. There's something we're supposed to do. What do we do? Do either of you know? Well, Juliana, do you know how to divide by fractions?
Mm-mm.
No. Ariana, do you know how to divide by
I
fractions?
remember.
Do you remember how to do
I
it?
think you multiply the whole thing by 6 over 6.
Yeah, not 6 over 6. You multiply by the reciprocal. You multiply the numerator
okay.
by the reciprocal of the denominator. That is, you flip the numerator and the denominator in the fraction in the bottom. And here's kind of why it works. Basically, what you're going to do is you're going to multiply the top and the bottom by 6 over 5. Right? And then this whole denominator, what does that equal in the denominator?
30?
No, well, 30 over 30, which is what?
1.
1, right? The 6 cancel out and the 5s cancel out. So you get 1 in the denominator. And then what do we get in the numerator? What's 1 times 6 over 5?
6 over 5.
6 over 5. So when x is 0, we get 6 over 5 in the expression in question. Does that make sense?
Mm-hmm.
Okay. Now here's the deal. The correct answer choice has to give us 6 over 5 when x is 0. Does that make sense, Juliana?
Yes.
Okay. So let's plug in, and maybe even before we plug in values, just look at the answer choices. I think we can eliminate a couple answer choices that I know are not going to give me 6 over 5 just by looking at them. What answer choice can we eliminate?
D, maybe?
D? Absolutely. What's D going to give us when x is 0?
0.
Not 0.
Ah. No, what word's being weird.
We'll get 0 squared, which is 0, plus 5 times 0, which is 0. So that becomes 0, that's 0, and we just left with 6, right?
Mm-hmm.
So D is 6. But look, it's not a fraction, right? When x is 0, right? We're not plugging in 6/5. We're plugging in a 0 for x. We set that value right here.
Mm-hmm.
So D's not going to give us 6/5. It's not going to give us a fraction of any sort. What else can we eliminate? Just by looking at it.
C.
C, right? It's not going to be a fraction either. That's going to give us 5.
Mm-hmm.
All right. So now let's plug in our x for 0 to the answer choices. Which one do you want to plug into, A or B?
A.
Let's plug into A. Let me see you work that on the whiteboard now.
So do I plug in the 6 over 5th where the x's should
Well,
be?
hold on. Is x 6 over 5 or is x 0?
X is 0.
X is 0, right? That's why you got. That's why I like really setting the value here, making that very, very clear. Because 6/5 is what we get when x is 0. into the expression of question.
5.
Looking good. Over 0 squared. Looking very, very good. You getting the hang of this whiteboard thing, Juliana?
Yeah, more or less. There.
Okay. Does that give us 6 over 5? No, it gives us 5 over 6. Right? So we can eliminate answer choice A. What about answer choice B?
Probably the right one.
Yeah, it's looking good, right? It's looking good. Let me see you plug it in. I'll clear some space for you. Or go ahead.
I think this is the right one.
That's looking good, right? Because we got a 6 in the numerator, and we got, we're going to get a 5 in the denominator. Bingo. We can confirm it. It's answer choice B. Any questions about that?
Nope.
Ariane, any questions about that?
Nope.
Now, this is a tough question. I mean, this is a tough question few students are going to get. Very few. Because the algebra is tricky. Very tricky.
And I also realized that B is basically the A.
Exactly, right? It's the reciprocal of A, right? And so once you solve for A, right, you'd be like, oh, I need the reciprocal, right? Which is B. So you don't even have to plug in for B, right? If you make that recognition. Great point. Great point. Any questions about this?
Nope.
No? Guys, how are you feeling about the SAT right now?
Pretty good. It seems more simpler once you break it down.
Absolutely.
In simpler terms.
It's just a question of it's a matter of looking at the questions the right way. It's a mindset I'm trying to teach you. Right? Again, it's not doing step operations. You know. I mean, again, there's arithmetic operations. Yes, there's no way around that. We got to do arithmetic. We got to do some math. All right. But it's learning to look at the questions the right way and the easy way. And if you can do that, you're going to get a really good score increase. I mean, to get a 100-point score increase, for example, on the SAT, all I need to do is get something close to 10 more questions right than you were getting before. Something close to that. Could be a few more, could be a few less, depending on the test. But something like 10 more questions right. Okay? And that's it. We're not going for perfection here. And a 100-point increase is massive. Right? I mean, that could be the difference between getting to the school of your choice or not, or getting, tens of thousands of scholarships or not. Just getting 10 more questions right. And you don't have to learn anything new. Again, I'm not teaching any new operations here, right? I'm just teaching you how to simplify the questions. And you can do this on almost all the questions with variables. Right? And I've got some more strategies, too, that are going to simplify different types of questions. We'll get to those as we move along the course. But this strategy, by far, this plugging values in place of variables, by far is the most useful strategy I can teach you. And it applies to more questions than any other strategy. I would say this applies to at least, certainly a quarter of the questions, between a quarter and half the questions on every SAT. Plugging the values in place of the variables. And it's so important. We're going to spend the first 2 days of the course just focusing on that because it's so useful. Okay. Do you guys have any questions for me?
Nope.
No? Okay, let's take a little break. We're going to we've got the next question coming. It's a little bit tricky. Let's take a little break, refresh ourselves. I'm going to use the restroom and grab some more coffee. You guys, I recommend doing the same. And I'll see you guys here after a little break, just a couple minutes. Okay. All right. Thank you so much. I'll see you soon. All right, welcome back, everybody, to SAT Math Crash Course Day 1, Part 2. We're just coming back from a little break, and we've got a new question up on the screen. This is question number 14. This was a little bit tricky. I ain't gonna lie, it's a little bit tricky. Very high-level difficulty question, especially if you're trying to think in algebraic terms. But we can simplify this by plugging in values in place of the variables. So let's Let's practice that strategy. I think, Juliana, you worked on the last one, so Ariane, it's your turn. Go ahead and read question number 14 for us, please.
Okay. If 3x minus y equals 12, what is the value of 8 to the power of x over 2 to the power of y?
Yeah. Woo. Okay. Yikes. What are we solving for here, Ariane?
The value of 8x over 2y.
Yeah, 8 to the power of x over 2 to the power of y. Absolutely. When 3x minus y equals 12.
Yes.
Okay. Whew. Whew. Okay. I ain't going to lie. The algebra on this is very tricky. It's very tricky. Okay. I might go over it here in a minute. But again, we can simplify this by plugging values in place of the variables. Okay. So we need values for x and y. Remember, we got to work within the limits of the question here. But as long as we come up with some values for x and y that work within the limits of the question, we can plug in anything to x and y here, and we'll get a true statement. Okay?
Okay.
So give me some values for x and y.
We could do x is equal to 1 and y is equal to 4. Or, no, sorry.
Well, remember, we got to work within the limits that they set right here. So we can pick anything as long as 3x minus y equals 12.
X is 5, so that would be 15 minus 3.
Yes. We can make x equal 5, and we could make y equal 3. We can absolutely do that. All right, because that gives us 15 minus 3, which is indeed 12. Okay, so we can do that. I think we can pick an even smaller set of values that are going to simplify this a little bit more. 3 and 5 would totally work. We can make it even easier, though. Can you think of a smaller set of values for x and y?
If we do x is negative 3. Sorry. No. X would be positive 3, so that would be 9. And then y is negative 3. So
that would work, 100%. It would work. I don't know if I want to deal with negative exponents.
Okay.
Okay? It would totally work. Anything, as long as the true statement would work. Here's what I want to plug in. I want to make x equal 4. And I'm going to make y equal 0. Do you see why that works?
Yes.
Right? Because 3 times 4 is 12, and minus 0 is 12. But you're right, 5 and 3 would work. I mean, anything. I've tested that. Anything as long as you get a true statement here would be fine. So, in fact, I know it would. But good. So this is what we're going to take those values. We're going to plug them into the expression here in the question. Let's see what we get. So if we do that, we get 8 to the power of 4 over 2 to the power of 0. Now, what does 2 to the power of 0 equal, Ariane?
1.
It equals 1. I'm so glad you know that. A lot of students don't. And as we're kind of getting to the rules of exponents here a little bit, I'm going to show you why it equals 1 here in just a minute. That equals just 8 to the power of 4 over 1, which is just 8 to the power of 4. Does that make sense?
Yes.
Okay. Ariane, do you understand why 2 to the power of 0 equals 1? Or no? Or you just know it?
I don't remember right now.
Yeah. It's something really interesting. As a student, I remember being taught that, and I was like, why does it equal 1? And like teachers were just like, just know that it equals 1. That's fine, right? But now I finally understand why it's the case. I'm going to explain to you real quick. It's kind of cool. So if I showed you, I'm going to give you another example, not directly related to the question here, but if I showed you x to the power of 5 over x to the power of 3, what does that equal?
X to the power of 2.
X to the power of 2, absolutely, right? Because you're like, well, you got 5 x's in the numerator, you got 3 x's in the denominator, they're all being multiplied. You can just cancel out 3 of the x's in the numerator and you get x squared. Does that make sense, Ariane?
Yes.
Juliana, does that make sense as well?
Yes.
Yeah, okay. All right. So now there's a simpler way to do it, sort of operationally, which is that as long as you have a like base, which you have here in x, right? This wouldn't work what we're about to do if it was x to the power of 5 over y to the power of 3. It's got to be x to the power of 5 and x to the power of 3, or divided by x to the power of 3. You can take the exponent from the denominator, bring it up to the numerator, and subtract it. So that gives us x to the power of 5 minus 3, but 5 minus 3 is just 2, so it's x to the power of 2. Have you seen that operation before, Ariane?
Yes.
Okay. Does that make sense? Also, Juliana?
Yes.
Okay. Now here's the deal. What if I showed you x to the power of 5 over x to the power of 5? What does that equal?
1.
That equals 1, right? Because anything divided by itself is 1. But operationally, remember, we can do the same operation. We've got a like base in x. All right? We can take the exponent from the denominator, bring it up to the numerator, and subtract it. So we get x to the power of 5 minus 5. That's x to the power of 0, which, yes, equals 1, because anything to the power of 0 is 1. But that's why. Because if it's raised to the power of 0, it means basically it's being divided by itself. Does that make sense, Ariane?
Yes.
Okay. Anyway, so just I don't know. I like understanding math and not just doing things because you're told to do it. So I don't like doing anything because I'm told to do it. I like understanding why. All right. So anyway, let's go back to the question at hand. So we know when x is 4 and y is 0, we get 8 to the power of 4. And by the way, we get the exact same thing when x is 5 and y is 3, by the way. I might get into y later, but let's just know right now that we get 8 to the power of 4. So the correct answer choice has to give us something equivalent to 8 to the power of 4. You might look at the answer choice and be like, well, I don't see 8 to the power of 4 there, and we don't. But I can start eliminating answer choices that I know don't equal 8 to the power of 4 with absolute certainty. Okay? First one I want to get rid of is I want to get rid of D. D is a distractor here. Okay? They're never going to say, we don't give you enough information to solve this question. They're never going to say that. I've seen it as some answer choices a couple times. Don't even worry about it. They always give you enough information. Okay? By the way, when I first did this question, I totally picked D because I didn't know how to solve it. So I was like, well, I don't give me enough information, so not happening. But just don't even worry about that. I would ignore that completely. Okay? Does that make sense, ladies?
Yes.
Okay. All right. What else, Ariane, can we eliminate with absolute certainty that we know is not equal to 8 to the power of 4? What can we eliminate?
C.
Absolutely. Right? 8 squared. Think about that for just a minute, right? That just means 8 times 8. And 8 times 8 just doesn't equal 8 to the power of 4, which is 8 times 8 times 8 times 8. Does that make sense?
Yeah.
All right. It's not complicated, right? It's just logic. Any others we can eliminate with absolute 100% certainty?
I think I can eliminate B.
Yes. Why? Explain. Tell me why.
Because 4 to the power of 4 is not 8 to the power of 4.
No, it's not.
I'm sorry.
Yeah. 4 to the power of 4 is 4 times 4 times 4 times 4. And that's just not going to equal 8 times 8 times 8 times 8. There's no way. Right? Now, you might look at answer choice A and be like, well, that doesn't look the same. And it doesn't. But at the very least, 8 to the power of 4 could equal 2 times itself 12 times. And it does. I'm going to show you why here in just a minute. But it could be true. But I know it's not B and I know it's not C, and we don't have to worry about D. So I would pick A. And if you did, you'd get it right. Does that make sense?
Yes.
Juliana, does that make sense as well?
Yes.
Okay. Let me show you why they're equivalent. We can express 8 in terms of 2. Okay? 8 in terms of 2 is 2 to the power of 3. That equals 8. Does that make sense why that equals 8?
Yeah.
Yeah?
Yeah.
Okay, good. So that equals 8, right? Because 2 times 2 is 4, times 2 again is 8. So 2 to the power of 3 to the power of 4 would be the same as 8 to the power of 4. Does that make sense why, Ariane?
Yes.
Juliana, does that make sense as well?
Yes.
Okay. Now you might be thinking, I guess you're thinking like, oh, I know I'm supposed to do something with those exponents right there. Do I add them? Do I multiply them? What do I do? Don't even worry about that. Think about what that expression means. 2 to the power of 3 to the power of 4. Think about what that means. All right? That means 2 to the power of 3 multiplied by itself 4 times. Right? So that's the same as 2 to the power of 3 times 2 to the power of 3, excuse me, times 2 to the power of 3 times 2 to the power of 3. Does that make sense, Ariane?
Yes.
Okay. And what does 2 to the power of 3 mean, Ariane? What does that mean?
2 times 2 times 2.
2 times 2 times 2. So that's 2 times 2 times 2. Times 2 times 2 times 2. I'm going to do this. Times 2 times 2 times 2. Woo! My handwriting's getting progressively worse. Times 2 times 2 times 2. How many 2's do we have here?
12.
12 2's. So that's 2 to the power of 12. Which is answer choice A. Does that make sense?
Yes.
And now we know what the operation was supposed to be. The operation here, we're supposed to multiply those exponents. But you don't even have to worry about the operation. Just think about what the notation means, and you can figure it out. Any questions about that?
Nope.
No?
Nope.
All right. All right. I'm tempted to show you the algebra here. Do you guys want to see it? Or do you think that would just be annoying and confusing?
That'd be good.
You want to see it? I'll show it to you. All right. I think that was a yes, right?
I don't mind.
You don't
I
mind?
know about you.
Okay. All right. You don't mind. I'll take that as an okay. All right, here's why, and I think it's going to make sense after we went over everything we just went over, why it is the way it is. Just clearing some space here. And let me zoom back in. Okay. So the operation they kind of want you to do here, algebraically, normally I don't think I go over this normally, but I think we got time. So they want you to sort of combine. Oh, sorry, I was on the erase function there. They want you to combine those exponents there, the x and y somehow. Okay, but you can't do that because you're gonna have a like base in. You've got 8 in the numerator and a 2 in the denominator. But again, if we create a like base in 2, and we're going to do that, we're going to express 8 in terms of 2, so that's 2 to the power of 3 to the power of x, right? Over 2 to the power of y. Does it make sense why those expressions are equivalent? This one and this one? Does that make sense, guys?
Yeah.
Yeah, okay. And now we know the operation, right, with the exponents up here. What do we do with those exponents?
Multiply.
Multiply them. So we get 2 to the power of 3x over 2 to the power of y. Does that make sense?
Yes.
Okay. All right. Now, and again, we've kind of gone over this operation already. We got a like base in 2. We can combine the exponents. So I can bring up that y from the denominator, bring it up to the numerator, and subtract it. And that's going to give me 2 to the power of 3x minus y. And we're actually very close to solving this now because we know what 2 to the power of 3x minus y equals. Well, what does 3x minus y equal?
12.
12. Look at the question, right? 3x minus y is 12. So that's got to equal 2 to the power of 12, which is the answer choice A. But I would never expect anybody to be able to figure out that operation on their own. It's very specific. It's very complicated. And you have to really understand like all of the properties of exponents. It's a very tough question. But you've got a good shot at it if you can just plug in values to the variables. Almost anybody can do it. Does that make sense?
Mm-hmm.
Okay. But yeah, I think the first way is the much easier way for the vast majority of students. So I recommend it. But this is a tough question. Very, very few students are going to get. But if you can plug in values to the variables, almost anybody can do it. I love this question. It's one of my favorites of all time on the SAT. Go ahead and read this for me. I think it's Juliana. Juliana, read number 16 for me, please.
If t is greater than, if 0 is greater than t.
No. You're right. And here, by the way, if you're confused about like inequalities, which one is bigger or whatever, I always turn the inequality into a Pac-Man.
Oh yeah.
Right, and it's like a middle school operation that I learned. Right, the Pac-Man wants to eat the bigger one. You know what I'm saying? Yeah. So t is greater than 0. I say do it. If you need to turn it to a Pac-Man, I recommend it wholeheartedly. All right. So take that again, Juliana, please, from the start.
If t is greater than 0 and t squared minus 4 equals 0, what is the value of t?
Okay. Now, Juliana, before we do any algebra here, before we think about like math operations at all, just look at it. I think Ariani's already laughing. Maybe Juliana's already laughing. Do you see the answer? Do you see what t has to be?
Greater than 0.
Well, it's greater than 0. You're right. We do have to work with that limit. It's not an equivalent expression question, so we can't ignore that. But do you see what, I mean, like, you know what t squared is going to have to be, right?
I think so.
Just look at it. What does t squared have to be? If t squared minus 4 equals 0, what does t squared have to be?
2.
No, well, t has to be 2. Right? Because t squared is 4.
Mm-hmm.
So t's got to be 2, right?
Yeah.
There's your answer. That's it.
That was easy.
That was easy. Nothing fancy.
We need to get one of those like buttons that are from Office It's that Office Depot store, and this is that. It was easy.
It's so easy. I like you'll see questions like this in the SAT that are so ridiculously, if you just look at them the right way, right? And you'll see students complicate this, like try to like square both, take the square root of both sides, and like then you're jacking everything up. But you don't have to think in those terms, right? Just be like, okay, just basic logic. What is 2 going to have to be, or what is t going to have to be? It's going to have to be 2, right? Because t squared has to be 4. It's that simple. Don't complicate this. All right. Now here's a crazy trick on the SAT. This is just nuts. And I've seen this confirmed time and time again. Every single practice test I've worked on, and we're talking practice tests 1 through 10, released by the College Board. And by the way, when you're doing prep on your own, it's very, very important that you use the practice tests that have been released by the College Board. Don't use third-party materials. Some of them are okay, but a lot of them, I'd say most of them, are very suspect. But on all the SAT practice tests released by the College Board, I've seen this. If you're solving for a variable, like x or like t here, and it's raised to a power greater than 1, so it's not a linear equation, right? It's a quadratic, or it's raised to the power of 3, raised to the power of 4. I've seen even raised to the power of 5. X is always, or the variable you're solving for, is always a value between 0 and 5. Always. Every single time. Every single time on the practice tests. Which makes sense, right? Because if it's raised to the power of like 3 or 4 or 5, they're not going to make x like negative 27.
Mm-hmm.
Right? Because then the problem would just be way too complicated. Because the values would just be way too complicated. And it's not going to be some crazy fraction. Right?
Yeah.
And it's not. It's always a value between 0 and 5. So if you see x raised to a power greater than 1, or any variable you're solving for, just plug in values between 0 and 5. Plug in a 0. Does that give you a true statement? No. That gives you 0 minus 4. It's a negative 4. Plug in a 1. Does that give you a true statement? No, it gives you negative 3. Plug in a 2. Does that give you a true statement? Oh, yeah, 2 works. Great. 2 is the answer. That's it. Don't complicate this. Plug in values. Any questions about that, Juliana?
Mm-mm.
Ariane, any questions about this?
Nope.
Every single question we've worked on so far is from the same practice test. In fact, we're still on section 3 of practice test 1. I'm not just picking the easiest ones from all the SATs. We're on the same practice on the same section. And the majority of these questions involve this strategy, or these 2 strategies of plugging in values and using common sense. Basic logic. Does that make sense?
Mm-hmm.
All right.
Yep.
Let's go to the next one. Okay, now I think this is actually from section 4. First time. Go ahead and read question number 8 for us, please, Ariane.
For what value of n is absolute n minus 1 plus 1 equal to 0?
Yeah, so we're dealing with, you're right, this is absolute value here. Juliana, are you familiar with absolute value?
Yes,
Okay.
a little bit.
A little bit. Let's review that real quick, because you do have to have that concept down. Okay, they do test you on specific math concepts in the SAT. And here I kind of want to show you how to use the basic concept cheat sheet that's on the rules for mathing. Right, here's the rules for mathing. We've got the first 4 rules. Again, we're going to focus on rule 1 and 2 in the first 2 days of the course. We will get to rules 3 on the 3rd day and rule 4 on the 4th day as well, when we talk about how to approach your prep on your own. But on the basic concept cheat sheet, if there's a concept they're testing you on the SAT, it's all here. It's all laid out. And this thing is powerful. I had one student in particular who signed up for my class. She didn't even attend the class. She literally just watched like 2 of the videos. And she studied the basic concept cheat sheet before the test. And she got a 130-point increase on the SAT.
Wow.
Which is crazy. Okay, now I'm not saying don't do the homework or don't attend the class. I'm not saying that. I mean, good heavens. I think that's I wouldn't expect that. All right. But she studied the cheat sheet and she really understood it. And she said, Mr. Toohey, the test was the cheat sheet. All right. And that's how I've designed it. I've reverse engineered this. I've gone through every single practice test and all the questions. And if there's a math concept they test you on, it's right here on the basic concept cheat sheet. So this is everything you need to know. So study this thing. It is very powerful. Okay. And we see basic concept J right here, absolute value. Do you see that on the screen, Juliana? Or I think Ariane, you're the one solving this one. Go ahead and read, Ariane, go ahead and read basic concept J, absolute value.
Okay, absolute value. Calculate what's inside the bars. If it's positive, keep it positive. If it's negative, make it positive.
Does that make sense, Ariane?
Yeah.
So what is inside that bar is going to come out positive. Right? If it's positive, just keep it positive. But if it's negative, just make it positive. That's absolute value. Does that make sense?
Yeah. Mm-hmm.
Okay, great. All right, so let's go back to the question. Let's test this on absolute value. And again, when you're doing this prep on your own and you see a question, you're like, what concept is that? Just check the basic concept cheat sheet. I've got sections on like quadratics. If you're doing a quadratic question, I got sections on systems of equations. If it's a systems of equations question, it's a word problem. I got a section on word problems. If it's a function, I got a section on functions. Go through that. Okay. In fact, I actually have a level 2 course where I go over every single concept, question by question. If you're interested, I can get you access to that. We can talk about that later. And I might be doing another live level 2 class at some point soon too. So just be on the lookout for communications about that. But anyway, you've got access to that right now as it is. All right, so we don't have to set up an equation here. We just plug in the values and place the variables here. How can we do that to find the right answer, Ariane?
So we put in 0 minus 1.
Yeah, let me see you do that on the whiteboard.
Okay.
Yeah, we're just testing the answer choices here. Again, don't think in terms of like, oh, what's the operation? Because I'll be honest, there's an algebraic operation with absolute value. I don't know what it is. I don't care. You don't need to know it for the SAT. You just don't. I'm going to make this real clear, by the way, for anybody watching the recording. This is the absolute value bars right here.
Thank you. Yes.
Okay, no problem. And you can write, yeah, great. See if it's equal to 0. Absolutely.
Mm-hmm.
Okay.
So that would be 1 plus 1.
Exactly right, because 0 minus 1 is a negative 1, but the absolute value of negative 1 is just positive 1. Again, we can make it positive if it's negative. Does that equal 0?
No, that would be 2.
That's 2, so we can eliminate answer choice A. Does that make sense?
Yep.
That's not complicated, is it?
No.
No, it's just arithmetic. Right? Don't try to do this algebraically. Don't. Avoid it if you can. It's complicated with absolute value. I'm not sure what the operation is. I don't know. But I don't want to know. Because you never need to know. I'm not going to complicate this. I'm a simple country boy. I want to keep it simple. All right. Go ahead and plug in 1 for n. We'll test the answer choice B. Is that a 1? Those are 1s, right?
Yes.
Yeah, okay, got you. No problem. It's 1 minus 1. Okay. What's the absolute value of 1 minus 1? 0, right? Because 1 minus 1 is 0. Absolute value of 0 is just 0.
That would be 1.
Is that a true statement?
No.
No, it is not. We can eliminate answer choice B. Let's try answer choice C.
Okay.
Looking good, looking good. Make those absolute value bars really clear.
That would be 1 plus 1. That would not equal to 0.
That's not equal to 0. So we can eliminate answer choice C. We can confirm it's answer choice D. There's no value. It's certainly not A, B, or C. It's got to be D. Which it is.
Mm-hmm.
Right? Which makes sense if you're really familiar with the concept of absolute value. You realize that thing coming outside of the absolute value bars, it's going to have to be positive. There's no way it's going to be negative. It's going to be 0. It's going to be positive. So the only way to make that equal to 0 is if the thing coming outside the absolute value bars is negative 1. There's no way that's possible. So just sort of, if you understand the concept, it's got to be D. But again, you can just test the answer choices and keep it really simple. Then you know it's not A, B, or C, so it has to be D. Any questions about that, Ariane?
No.
No? Okay. Juliana, any questions?
No.
All right. Now you might be like, well, what about 1 through 7? 1 through 7 are so easy on this test. They're like, there's some word problems and they're real common sense, and we just don't want to go over them right now. But again, we're focused on the plugging in value strategy. But this is still from the same practice test. That's section 4. Ooh, questions 9 and then 10. Well, I'll add 10 here in a minute. Go ahead and read for us, please. Juliana, read the introduction to 9 and 10, and then we'll solve this.
Mm-hmm. The speed of a sound wave in air depends on the air temperature. The formula above shows the relationship between A, the speed of a sound wave, in feet per second, and T the air temperature in degrees Fahrenheit.
Okay. Go ahead and read the question now, please.
Which of the following expresses the air temperature in terms of the speed of a sound wave?
Which of the following expresses the air temperature in terms of the speed of a sound wave? What are we solving for here, Juliana?
The expression that shows the air temperature in the speed of the sound wave terms.
Yeah. Yeah, and what variable is the air temperature? It tells us in the question.
Air temperature is T.
Air temperature is T, right? I mean, they tell us that in the question, right?
Mm-hmm.
So which expresses the air temperature in terms of the speed, which is A? That's really kind of a fancy way of saying, like, isolate T, get T alone.
Mm-hmm.
Okay, and if you look at the answer choices, I think it makes a ton of sense. All the answer choices have T by itself on the left-hand side of the equation, and then everything else on the other side. Does that make sense?
Mm-hmm.
So if you're not quite sure what you're what the question is asking you, sometimes the answer choices kind of give you a little bit of a clue here. But again, this is just like SAT code language, right? Which expresses this variable in terms of the other variables. It's isolate that first variable. That's what they're saying.
Mm-hmm.
Okay. Now there's an algebraic way to do this. We can just isolate T from this equation right here. If you're really comfortable with it, and that's easy for you, you can do that. That's fine. I'm not saying you can't do algebra, but there's a really, really easy way to do this. We can plug in values and place the variable and solve it.
Mm-hmm.
Okay? So let me show you what that looks like. I'm going to set a value for T, and I'm going to make T equal 1.
Mm-hmm.
Okay? Notice I'm not starting with A.
Yeah.
Okay? I'm not making A equal 1, because if I make A equal 1, then I still got to solve. I got to do some algebra and kind of solve for T. I got to find what T equal, and I don't know. It's really complicated.
Yeah.
But if I start with the more complicated side of the equation, plugging values in the more complicated side, which is all we've done, right? We always start with the more complicated side. Then it's just basic arithmetic to solve for the variable on the left-hand side. That's by itself. Does that make sense?
Mm-hmm.
Because I can just look at that and be like, oh, I know what A is. What is A, by the way, when T is 1? What's A? You don't even have to use a calculator. You can, this is the calculator section, so you can use a calculator if you want to. But what's A?
Calculator.
Yeah, you can use the calculator if you want. It's just going to be 1,052 plus 1.08.
Mm-hmm. 1,053.08, I think.
Yep, you're absolutely right. All right, any questions about that? Or does that make sense why that's the case?
Yeah, that makes sense.
Okay, Ariane, any questions about that?
Nope.
Okay, we know when T is 1, A is 1,053.08. Okay, great. So we're trying to find an equivalent expression here.
Mm-hmm.
Okay. And we're finding the one that isolates T, but it's the correct answer choice still has to be a true statement. When T is 1, A has to be 1,053.08 in the correct answer choice. So let's plug those values into the answer choices and let's see what we get. Okay. So, and just for the sake of simplicity, I'll plug these in here on the whiteboard. So I'm going to test answer choice A first. And instead of T, we're going to write 1 equals not A, we're going to write 1,053.08 minus 1,052 over 1.08. Okay. Juliana, does that give us a true statement?
Yes.
Yeah, I think it does, right? Because we get 1.08 in the numerator, and we got 1.0 in the denominator. Anything divided by itself is 1. So that gives us a true statement. Let's keep A. Let's keep A. Let's take a look at answer choice B. I don't even have to plug it in, I don't think. I'm just looking at it right now.
That doesn't look right.
Is that going to give us a true statement?
No.
No way. No way. Ariane, does that make sense why that's not going to give us a true statement if we plug in 1053.08 for A into answer choice B? Does that make sense? Right, we're going to get like 2,000 something in the numerator and something close to 1 in the denominator. There's no way that's going to be equal to 1. It's going to be closer to 2,000. So B is gone. What about answer choice C? Just look at it, Juliana.
It could be.
It could be.
It's just opposite order.
Let's calculate it. Let's do it. I'm going to clear some space. So we've got 1,052 minus 1,053.08. What does that give us?
Negative 1.08.
In the numerator, negative 1.08 divided by 1.08. That's going to be negative.
Yeah.
It's not going to be equal to 1. Remember, that's got to equal 1. Positive 1. That gives us negative 1, but not positive 1. So we can eliminate C, right? And if you look at answer C and you realize, like, oh, that's going to be negative, right? Because 1,053.08 is bigger than 1,052. You realize it's going to be negative, and so it can't be 1. It can't be true. What about answer choice D? Is that going to give us 1 for T?
No.
No. You can just look at it and be like, no, there's no way that's going to work. So we confirm it's answer choice A, which it is. Any questions about that? Now, the algebra is not complicated here. Again, if you're really comfortable, you can do it. But you're guaranteed to get it if you turn it to arithmetic. There's nothing to mess up if you can do arithmetic. Nothing. And you'll get this one right. The next one, so this is where we see 9 is still back here. 10 is, and 9 and 10 are related. Okay. Go ahead and read, Ariane, go ahead and read question number 10 for us, please.
At which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second?
Okay. We don't need to do any algebra here. We don't. What are we solving for here, Ariane?
The temperature
Yeah.
when sound wave will be 1,000 feet per second.
Yeah, absolutely. The air temperature when the speed of a sound wave, right? Remember, air temperature is T, and the speed of a sound wave is A, right? So when the A is closest to 1,000 feet per second. Well, they give us the equation up here, right? How can we just plug in values to find the right answer?
Or we can put the different options in A.
Absolutely. Well, hold on, not in for A.
Oh, sorry, T.
For T, right? Because T is going to be either negative 46 or negative 48 or negative 49 or negative 50.
Yes.
It's going to be one of those, right? So you got to remember, you don't just plug in anything for anything. You got to plug in the right things for the right things. So plugging the answer choice for T, and the right answer choice has to give us something close to what?
1,000.
1,000 for A. Does that make sense?
Yep.
But it's just arithmetic. Let's do it. Let's test the answer choices. Okay? So I'll work it out again here, but I need you to. Do you have a calculator handy?
Yes.
Okay, great. So it's going to be one. We'll test the answer choice. It's 1,052 plus 1.08 times negative 46. Okay, and what does that give us?
1,007.08.
1,007.08. Pretty close
Mm-hmm.
to 1,000. Let's test answer choice B. What does that give us?
$1,005.08.
Ooh, 1,005.08. Let me. Ooh, I don't even have my calculator. Is that what you're getting, Juliana, as well?
Yes.
You getting the same? Okay.
Mm-hmm.
Let's test answer choice C.
I would think it would be 1,004.08 because it's just one different.
Are you doing well? Hold on. Are you multiplying 1.08 times negative 48?
I think so. Oh, sorry, it didn't come out on the calculator.
Okay. Do that first. Do 1.08 times negative 48. I think you might get something different. I don't have my calculator with me.
I just did the math and I got 1,000.16.
Yeah, I think I think that's what I get
Okay.
normally. And what about A? Double check A, Juliana, as well. Do you know where you're going wrong here, Ariana? I think you're having some
Yeah.
Where were you going wrong? What were you doing?
I'm not sure how to make the 48 negative.
Don't worry about that. Just find out what it is and then subtract it from 1052. You know what I'm saying?
Okay. Yes.
Juliana, I want you to double check answer choice A.
I got 1002.32.
Okay. I think that's closer. Does that make sense now, Ariane?
Yes.
You said 1002 point what? Juliana?
1002.32.
0.32. Okay. Okay. So far B is the closest. Does that make sense?
Mhm.
Okay. Let's try answer choice C. We're plugging in negative 49. Again, just multiply 49 times 1.08 and then subtract it from 1052. Remember, this is kind of a PEMDAS thing, right? You've got to multiply first before you do the addition and subtraction. You guys familiar with PEMDAS? Okay. If you're confused about PEMDAS, by the way, I've got a section on the rules for mathing. I think at the very end, I've added it recently. Order of operations. Use that to guide you if you're working out the arithmetic.
I got 999.08.
Ooh, 999.08. Ooh, which one is closer, by the way? B or C? Which one's closer to 1,000?
B.
B is closer, right? It's only 0.16 away, and C is like 0.92 away. They're both close, but B is closer. And by the way, we can eliminate A because that's not even close. And it's not C, but I think D is going to give us something even smaller than C, right? Because it's a bigger negative number. Does that make sense?
Yes.
Yeah. So we can eliminate D as well. Confirm it's B. I mean, if you wanted to be very, very, very safe and test D, you could. But to save time, I feel pretty comfortable logically eliminating D without doing the calculation.
Yeah, I did the calculation and it's 998.
Yeah, it's going to have to be smaller, right? Because you got a bigger negative number. So, any questions about that, either of you, ladies?
Nope.
No. But you see how you don't need to set up an equation here. You don't need to do algebra here. I don't recommend it.
Yeah.
You just don't need to. It's going to complicate it. Just test the answers. I'm going to do a couple more. All right, question number 11. Let's go to Juliana.
Okay. Which of the following numbers is not a solution of the inequality 3x minus 5 is greater than or equal to 4x minus 3?
Which of the following numbers is not a solution to that inequality? Juliana, what are we solving for here?
The inequality, which is not the solution, which isn't the solution.
Which one isn't a solution, right, to that inequality? And here's the deal: that means we've got 3 answer choices that are a solution to that inequality. Does that make sense?
Yes.
And only one that's not a solution to that inequality. Okay. So let's find the one that's not. How can we solve that? By plugging in values for the variables. How can we solve that?
Yep.
What would that look like?
You plug in the values given for x.
Yeah.
And see which one's greater than or equal to.
Yeah. See which one doesn't give us a true statement. And that's the tricky part here. When they put something in all caps and they underline something, you got to make a note of it.
Yeah.
All right, because if you get a true statement, you're like, oh, that works, but that's not the right answer. You want the one that doesn't work, which is a little bit tricky here. Keep that in mind. So let me work this out. Plug those answer choices in for x, and we'll see which one doesn't give us a solution. You've gone lavender. Very nice.
Yeah, changing it up.
Looking very, very good.
Mm. I think that's the first one.
Yeah, that looks pretty good. So we get -8 is greater than or equal to -7. Is that a true statement, Juliana?
Yes.
Ariane, is that a true statement?
Is it?
No,
No, it's not. Why not, Ariane?
because -7 is greater on the number line than -8.
Well, here's the deal. Look, -8 is smaller than -7.
Oh, yeah.
It's more negative. Does that make sense, Juliana?
Yeah.
It's more, and right, if you think in terms of the number line, it's farther over to the left-hand side on the number line. It's more negative, which means it's smaller, right? I mean, -1,000,000 is really small, right?
Yeah.
If you have -1,000,000 in your bank account, you're pretty poor, right? In fact, you're deep in debt, right? You're in big trouble. You got a -1,000,000, right? It'd be better off if you had only -$7 in your bank account. You'd be a little bit richer, right? Does that make sense?
Yeah.
All right. So, is -1 a solution to that inequality?
Mm-mm.
No, it is not. No, it is not. Which means A is looking pretty good. Does that make sense? Does that make sense? Why it's probably A.
Yeah.
I might double check here. In fact, let's do that. Let's plug in a -2 for x. I'll clear some space on the whiteboard. Let's plug in a -2 for x. And if it gives us a solution, we can eliminate it. Let me see you do that. Looking very, very good. Looking great. -6 -5. Excellent. Ariane, is all this arithmetic making sense?
Yes.
Okay, good. Yep, so we get -11 is greater than or equal to -11. So is that a true statement, Juliana?
Yes.
Yes, it is. It's greater than or equal to. It's equal to, right? So that gives us a true statement, which means we can eliminate answer choice B.
Yeah.
Make sense?
Mm-hmm.
Okay. And we could confirm it. I mean, we could plug in the -3 again if you wanted to. For the sake of time, we've already found the one that doesn't give us a solution. I feel pretty comfortable that doesn't give us a solution. So we could stop there and stop with A. Now again, if you're creating your own values, you have to go through all the answer choices. If you're creating your own values. Because sometimes if you're plugging your own values, you might get more than one answer choice that gives you a true statement. If you're creating your own values. If you're plugging the values in from the answer choices and you find something that solves it, you can probably stop there. So you can spend more time on the other questions. Any questions about that?
Nope.
No? Ariane, any questions about that?
Nope.
Now you can solve this algebraically. You can isolate x. You know, if you're doing, you know, you can deal with inequalities just like you can deal with equations and isolate variables. The tricky part with inequalities, and I think I have a section actually on the rules for mathing, is that if you multiply or divide both sides by a negative, you've got to flip the sign. Everybody forgets that. I don't know if that plays a role in this question. I don't think it does. But just be aware that sometimes that throws you off. But you don't even have to worry about that if you're just plugging in values because you're not doing an operation. You're just doing arithmetic. Okay? Okay. Let's do one more. Normally we don't actually get this far in the question sets. You know what? I might save this one for later. No, we'll do this. We might go over these at the beginning of the next class, just to let you know, because when I send the recordings out, I don't think I get into these questions until the day 2. But we got a couple minutes left, so let's solve this one. Probably wrap it up here with this one. But be aware, we might go over it again, but that's cool. Go ahead and read. Let's do. That was Juliana, right? So Ariane, go ahead and read question number 16 for us, please.
you want me to read the graph description?
Yeah, go ahead. Absolutely.
Okay. The graph above displays the total cost, C, in dollars, of renting a boat for H hours.
Okay.
So which of the following represents the relationship between H and C?
Okay. Which of the following represents the relation between H and C? This is a good question. This is kind of a fancy way of saying what's the equation of the line. Does that make sense why that's the case?
Yes.
Right?
Mhm.
Right. What's the relation between H and C? I mean, that's the equation. Okay.
Mhm.
And if you're familiar with y equals mx plus b form, and what is that? Slope intercept form is what they call it. Y equals mx plus b. Are you guys familiar with that? Y equals mx plus b.
Yes.
Yeah. You can think of those terms and solve this question, although it's a little bit tricky. I'll show you why here in just a minute. But you can think of those terms and find the answer. You can. But we don't need to do that. We don't need to think of those terms. We can turn this into arithmetic by plugging in values in place of the variables. All right? Anytime they give you a line, which we have here, we got a line, and there's points on the line, we've got a lot of x, y values, right? Or in this case, it's h and c values, right? Because h is like the x-axis, c is like the y-axis. Does that make sense?
Mhm.
Yeah. So we've got a bunch of x, y values. We can plug in to the answer choices and see which ones give us a true statement. And then we're just doing arithmetic. Does that make sense?
Yep.
Yeah. Okay, great. So let's pick a point. I'm going to pick, well, let's start with this point right here. That's the point, that's 0, 5. All right? Because we know when h is 0, c has to be 5. Does that make sense?
Yes.
Okay. So, and Ariana, you're working this one out, right? I think.
Yep.
Let's plug those values into the answer choices, okay? And let me see you work that out. All we got to do is plug in a 0 for h and a 5 for c, and we'll see if we get a true statement. The correct answer choice has to give us a true statement. So let me see you do that.
Okay. Sorry, is that? No, that's.
C is 5. Yeah, so it's gonna be 5 equals. Five times 0. Excellent. Is that a true statement, Ariane?
No.
No, we can eliminate answer choice A, right? Because we know when h is 0, c has to be 5, and that's just not true in answer choice A. Let's try answer choice B. I'll clear some space for you. You can solve in the same spot. Okay. Does that give us a true statement?
Yes.
Yes, it does, right? Because 3/4 times 0 is 5. 3/4 times 0 is 0. 0 plus 5 is 5. So let's keep answer choice B. Let's try answer choice C.
Okay.
Does that give us a true statement?
Yes.
It also does. So we can't eliminate C. We can't, okay? And I intentionally chose this point on purpose. I could have picked another one that'll give us the right answer right away. But I wanted to show you that sometimes when you're plugging in values, you're going to get multiple answer choices that give you a true statement.
Okay.
Okay? It happens. And that's okay. Okay? Because then we'll just plug in another set of values. But let's plug that same set of values into D, though. Okay, I'll clear some space again. Go and plug in our 0 for H and our 5 for C. All right, does that give us a true statement?
No.
Definitely not. We can easily eliminate D. That's no problem. Okay, so now it's between B and C. Okay? But we don't have to stop there. We can just pick another set of points. Okay? To find the right answer.
Okay.
So let's pick this other point right here. Again, smaller values are generally going to be easier, right? And that point right there, that's 1, 8. Do you see that?
Yes.
So the H value is 1, the C value is 8. So let's plug that in. We don't have to worry about A and D are gone. So it's just B and C now. So plug in 1 for H and an 8 for C, and answer choice B. Does that give us a true statement?
No.
No, it doesn't. And here, don't even worry about like doing the actual like math operation. You can use that basic logic again, because I don't care what 3/4 plus 5 is. I know it's not equal to 8. Does that make sense? I mean, 3/4 isn't even 1, and 1 plus 5 is 6. So it's gonna be less than 6, whatever that is. I mean, it's 5 3/4, but you don't even have to worry. It's just not a true statement. So B is gone. Let's try answer choice C. See if we can confirm it.
That's true.
That is a true statement, right? 8 does equal 8, so we can confirm it's answer choice C. Oops. So circle it, not erase it. There we go. Any questions about that, ladies?
Nope.
No? Now you might be thinking like, well, I know y equals mx plus b form really well, so I'll probably do that next time. But here's the tricky part. If you think in y equals mx plus b terms form, right? B is the y-intercept. You guys are familiar with that?
Yeah.
The y-intercept, right? And then the m value is the slope, which is the rise over run, right?
Yeah.
And if you're calculating the rise over run here, most students, when they calculate the rise over run, well, guess what they calculate the rise over the run as?
3/4.
They generally calculate 3 or 4 because you count the boxes, right? If you go from this point to this point, they're like, oh, up 3, 1, 2, 3, and over 4, 1, 2, 3, 4. 3 over 4. Okay? And everybody picks B for this question because they're counting boxes. But on the SAT, and I've got a section on the basic concept cheat sheet on graphing. I would love it, Ariani, if you would read the third bullet point on graphing.
Always pay attention to the units on the XY axis. They are not always intuitive. 1 square does not necessarily represent 1 unit. When calculating slope, it's not the number of squares, it's the number of units.
It's the number of units, right? And if you look at the units, you're going up 3, 1, 2, 3, over 1. So the slope is 3, which is answer choice B. Or answer choice C. Sorry. I know my letters. Answer choice C. Does that make sense?
Yeah.
That's really tricky. A lot of students get tripped up on that. Be aware, they love messing with the units on the XY axis to throw you off. But you eliminate that completely when you plug in values. So I like looking at it this way too. Yeah, and there's always more than one way to solve these. Always. But I think the arithmetic way is generally the easiest. All right, and you're likely to avoid some of the silly classic mistakes. Do you ladies have any questions right now?
Nope.
No? Okay.
No.
Let's wrap it up there. So here's what I want you to do. I'm going to send you a document that has all of these questions that we worked on today and a couple new ones. Okay? Not a ton, just a couple. And I want you to solve all of the ones that we've worked on our own together, but I want you to solve them using the strategies that we've been working on today. Okay? Not thinking in like math terms or math class terms. It's not like a math test, like you've been taking in school. Okay? So practice solving the questions using the strategies I'm teaching you in the course. If you don't remember exactly how to solve one of the questions, no problem. Go back and review the video and figure out how to solve it. And then practice solving on your own until the solution's automatic. Does that make sense?
Yep.
That's going to be the key to your success. It's practicing solving these the right way, practice solving these using the strategies I'm teaching you, turning everything to arithmetic. Okay? And then with practice, that way of approaching the questions is going to become automatic, and you're going to rock the SAT if you can do that. But you got to practice it, okay? Don't think like, oh, I understand all these, so I'm good. It's like, no, you got to practice doing it. Doing it, right? They say, we don't rise to the level of our expectations. We fall to the level of our training. Okay? Especially under stress. So on the SAT, if you're stressed out, you're freaking out about time and all this stuff, you're going to do what you always do, which is like math class math. And this is not it. You got to train yourself to think in these terms. Does that make sense, ladies?
Yes.
So do the homework. Practice the problem sets that we've gone over in the videos. Again, look for the solutions if you don't remember exactly how we solved it. and then try the new ones. If you don't know how to solve those, don't freak out about it because we're going to go over all the new questions at the beginning of the next day's course. Does that make sense?
Yep.
Okay. Any questions?
Nope.
No? How are you guys feeling about the SAT right now?
Better.
Good. You should. You guys are doing great. I mean, you guys are catching on fast. I'm very, very impressed. Very impressed. And if you can learn to approach it this way, you're going to be in really, really good shape. Got to do the practice, got to do the work, but we're just getting started. So for the next day's course, we're going to practice the strategy a little bit more, plugging in values for the variables. On the day 3 of the course, we're going to do some geometry, SAT geometry. I'll show you how to solve it. It's really, really easy. It's just visual estimation. We'll get to it all. I've got some tricks for that one. And then the last day of the course, we'll go over some of the more commonly tested concepts on the SAT. And we're not going to cover everything. That's not kind of the scope of the course. It's not to teach you every single little thing on the SAT. That's not how you get your score increase. You get your score increase by simplifying the questions and by getting the ones you should be getting in the first place. And if you can do that, you're probably going to get something close to 10 more right at least. And again, that's enough to give you something around a 100-point increase, which is great. Okay. All right. Well, thank you so much, ladies, for your participation. I really appreciate it today. You guys did great. And I'll see you next Saturday, okay?
Okay, thank you.
All right, thank you so much. Let me know if you have any questions. I'll send out that email that's got the links to the videos and everything, and the links to the homework too, okay? All right, thank you so much. I'll see you guys soon.
Bye.
Bye.
All right, thanks.